Could we live inside a black hole? It sounds like a question from a late night talk with friends. Or maybe the plot of a science fiction movie. The simple answer is no, of course not. A black hole is a cosmic monster. It crushes things. It's the end of the line. But the simple answer isn't always the whole story. The truth is, we don't fully know what a black hole is. Or, more accurately, we don't know what's at its very center. Our best theories of the universe break down when they try to describe it. And in that breakdown, in that gap in our knowledge, there's a sliver of possibility. A space for wild ideas. So let's explore that space. The question isn't just about survival. It's about what the universe is really like at its most extreme. First, we need to be on the same page. What is a black hole? Forget the image of a cosmic vacuum cleaner sucking things up. It's not a hole in that sense. It's an object. It's a huge amount of matter squeezed into an incredibly small space. Imagine taking the entire Earth and crushing it down to the size of a marble. Now imagine taking a star, many times bigger than our sun, and crushing it down to the size of a city. The gravity of that object would be immense. Everything has gravity, you have gravity. The device you're reading this on has gravity, but it's tiny. The Earth has more gravity, which is why we stick to it. To leave Earth, you need to go fast. Rockets have to hit about 25,000 miles per hour to escape Earth's gravity. That speed is called escape velocity. A black hole is just an object with an escape velocity that's faster than the speed of light. And since nothing can travel faster than light, nothing can escape. Not a rocket. Not a radio wave, not even light itself. That's why it's black. The border where the escape velocity becomes faster than light is called the event horizon. It's not a wall or a surface, it's a point of no return. Think of a powerful river flowing towards a giant waterfall. And far upstream, you can paddle your canoe around easily. As you get closer to the waterfall, the current gets stronger. At some point, you cross an invisible line where the water is flowing faster than you can paddle. No matter how hard you try, you're going over the edge. The event horizon is like that. Once you cross it, you're going to the center. There are no other options. So, let's imagine we're on a journey. We have a special spaceship that can withstand incredible forces. We fly towards a black hole. For this trip to even be thinkable, we need to choose the right kind. A small black hole, one with the mass of a star, would be a terrible choice. The gravitational pull would be so different on your feet than on your head that you'd be stretched apart like spaghetti. This process has a name, and it's fittingly called spaghettification. You would be torn into a stream of individual atoms before you even reach the event horizon. Not a great way to start our new life. We need a much bigger one, a supermassive black hole. These are the giants that sit at the center of most galaxies, including our own Milky Way. They can be millions or even billions of times more massive than our sun. Because they are so large, their gravity is more gentle over short distances. The difference in pull between your head and your feet would be tiny. You could cross the event horizon without even noticing. One moment you could, in theory, turn around and fly away. The next moment you can't. But nothing would feel different. No alarms would go off. No jolt. You'd just be inside. What would you see? Looking back, the view would be strange. The light from the entire universe you left behind would be distorted and squeezed into a small, bright window. And because of the extreme gravity, time would be behaving very differently. For you, time would be passing normally. But looking out at that window to the universe, you would see time speeding up. You'd watch stars being born and dying in seconds. You'd see galaxies evolve in the blink of an eye. The entire future of the universe would flash before you as you fell deeper inside. Meanwhile, anyone watching you from the outside would see something else. They'd see your spaceship slow down as it approached the event horizon. They'd see you get redder and dimmer, frozen in time right at the edge before fading away completely. They would never see you cross. So, we've made it. We're inside a black hole. We survived the crossing. Now what? According to our current best theory of gravity, Albert Einstein's general relativity, our journey is almost over. And it ends badly. General relativity says that at the center of a black hole is something called a singularity. All the mass of the black hole, all the mass of the original star, and anything else that has ever fallen in is crushed into a point of zero size and infinite density. All of it. The laws of physics as we know them stop making sense at a singularity. Inside the event horizon, the fabric of space-time is warped in a very particular way. Out here, in our normal universe, we are free to move in any direction in space. We can go left, right, up, or down. But we are forced to move forward in time. You can't stop time, and you can't go back. Inside a black hole, those roles of space and time get swapped. Once you cross the event horizon, you can no longer move freely in space. There's only one direction you can go towards the singularity. It's not a place you travel to, it's a moment in your future. Just as we are all moving towards next Tuesday, an astronaut inside a black hole is moving towards the singularity. There's no steering away from it. It is their future, and that future is maybe a few hours or days away, depending on the size of the black hole. The end is being crushed out of existence. In this picture of the universe, the classical Einsteinian view, living inside a black hole is impossible. You get in, you have a strange view for a little while, and then you die. End of story. For a long time, this was the accepted answer, but science is never that settled. The idea of a singularity, this point of infinite density, has always made physicists uncomfortable. Infinity is usually a sign that your math is broken. It's a red flag that your theory is missing something important. General relativity is a fantastic theory for describing big things like planets and galaxies. We also have another fantastic theory, quantum mechanics, for describing very small things like atoms and particles. The singularity at the center of a black hole is both. It has immense gravity, so you need general relativity. But it's also infinitesimally small, so you need quantum mechanics. The problem is, these two theories don't play well together. They speak different mathematical languages, they contradict each other. When we try to use both to describe the center of a black hole, the equations spit out nonsense. This means that the singularity probably isn't a real thing. It's not an infinitely dense point. It's just a placeholder. It's a sign that we need a better theory, a theory of quantum gravity that can unite the world of the big with the world of the small. We don't have that theory yet, but physicists have some ideas about what it might look like. And it's in these new ideas that the possibility of living inside a black hole starts to open up. One idea comes from string theory. String theory suggests that all the fundamental particles in the universe aren't points, but tiny vibrating loops of string. Different vibrations create different particles, just like different vibrations of a guitar string create different musical notes. In this view, a black hole isn't a point of infinite density. Instead, when a star collapses, all the strings that made it up get tangled together into a giant, messy, ultra-dense ball. Some call this a fuzzball. There would be no empty space inside the event horizon. There would be no singularity. The entire black hole, right to its edge, would be filled with this fuzzball of strings. If you fell into a fuzzball black hole, you wouldn't be crushed at a central point. Instead, your own strings would get tangled up and incorporated into the fuzzball. Your information wouldn't be destroyed, it would just become part of the larger object. You wouldn't be living inside it in any normal sense. You would cease to exist as you, and your fundamental components would become part of the black hole. It's a different fate, but still not one you'd sign up for. Another alternative is the gravastar. This is a more exotic idea. It proposes that just before a singularity can form, the nature of spacetime itself undergoes a kind of phase transition, like water turning into ice. The matter that fell in would form an incredibly thin, super strong shell of exotic matter right around where the event horizon would have been. Inside this shell, it could be a patch of empty space or something stranger. A gravastar would look like a black hole from the outside, but it would have no singularity. It's possible you could pass through this shell, but we have no idea what the conditions would be like or what you would find on the other side. Then there are ideas from a field called loop quantum gravity. This theory tries to build spacetime out of tiny, indivisible chunks. Think of it like a digital image. If you zoom in far enough, you see individual pixels. Loop quantum gravity says space itself is made of these pixels. You can't have a space smaller than one of these fundamental units. This puts a hard limit on how much you can crush something. In this model, when a star collapses, it doesn't form a singularity. It gets squeezed down until it can't be squeezed any further due to this quantum pressure. It forms an object of incredible density, sometimes called a Planck star. This object then rebounds. It explodes, but because of the extreme time dilation near the event horizon, this bounce would take billions or even trillions of years from an outside observer's perspective. From inside, it would be much faster, so if you fell in, you might not be crushed into a singularity. You might be caught in this process of collapse and rebound. What that would feel like is anyone's guess. These ideas are all attempts to solve the singularity problem. They replace it with something else, something physical that our theories can handle. A fuzzball, a shell, a bouncing core, none of them sound particularly comfortable. But They move us away from certain death and into the realm of the unknown, and that unknown leads to the most mind-bending possibility of all. What if the rebound of a collapsing star doesn't just push matter back out? What if it creates a whole new universe? This is an idea known as cosmological natural selection, or the black hole universe hypothesis. The concept is that when a star collapses to form a black hole in a parent universe, the incredible density at its core triggers a new Big Bang. A new universe blossoms into existence, expanding outward from the black hole's center. This new baby universe would be forever hidden behind the event horizon of its parent black hole. It would be causally disconnected. No one from the parent universe could ever look inside and see it. And no one from the baby universe could ever look out and see their parent. If this idea is true, it could answer some big questions. It could explain where our own Big Bang came from. Perhaps our entire universe, all the galaxies, stars, planets, and people exist inside a black hole that itself exists in some larger, older parent universe. We wouldn't know it. For us, our universe looks vast and maybe infinite. The laws of physics seem consistent everywhere we look. This theory suggests that black holes are like cosmic wombs, creating new universes with slightly different physical laws. The universes that are good at making more black holes are the ones that have more children, and so that kind of universe becomes common. So, could we live inside a black hole? In this scenario, we already are. Our existence is the proof that life is possible inside one. But let's go back to our original journey. We're in our spaceship, and we've crossed the event horizon of a supermassive black hole in our own universe. What if that black hole contains another universe? Could we travel into it? Here, we're deep in speculation. If we survive the trip to the center, and if the singularity was replaced by a gateway to a new universe, what would we find? We would be entering a new space-time. The physical constants might be different. The strength of gravity, the speed of light, the charge of an electron, all the fundamental numbers that govern our reality could be slightly altered. It's possible that this new universe would be a chaotic, sterile place where stars and planets could never form. It could be a high-energy furnace or a cold, empty void. Life as we know it would be impossible. But it's also possible that it would be similar to our own. Maybe we'd emerge from what looks like a white hole, the opposite of a black hole, spewing matter and energy out into a new, young, expanding cosmos. We would be the ultimate aliens. We would be beings made of matter from an older universe. We could never go back. We could never phone home. We would have to start over in a new reality. The practical challenges are overwhelming. The environment would be hostile. We would be utterly alone. But it's a theoretical possibility for survival. It's not just living inside a black hole, but living through one. This all hinges on theories that are at the very edge of our understanding. We don't have the technology to test them. We can't create a black hole in a lab and poke it to see if it's a fuzzball or a gateway to another dimension. All we have are mathematics and thought experiments. There's also another major problem to consider: information. There's a fundamental principle in physics that says information can't be destroyed. Information is the specific arrangement of things. If you burn a book, you might think the information is gone. But in theory, if you could track every single atom of smoke and ash, you could reconstruct the original book. The information is just scrambled, not erased. Black holes seem to violate this rule. If you throw a book into a black hole, it seems to be gone forever. The black hole's only properties are its mass, its spin, and its charge. It doesn't remember it was made from a star, a book, or a spaceship. This is called the black hole information paradox. Stephen Hawking discovered that black holes aren't entirely black. They slowly leak radiation, now called Hawking radiation, and eventually evaporate over immense timescales. But the radiation that comes out seems to be random. It doesn't contain the information of what fell in. So, where did the information go? Solving this paradox is one of the biggest challenges in theoretical physics. The fuzzball idea is one solution. The information isn't lost, it's just woven into the strings of the fuzzball. Another idea is that the information is somehow imprinted on the event horizon itself, like a giant cosmic hologram. Or maybe the information does escape, hidden in subtle quantum connections within the Hawking radiation. What this paradox tells us is that our picture of a black hole as a simple object with a destructive singularity is probably too simple. Something more complex and interesting must be happening. The universe doesn't like to throw things away for good. So, let's step back and take a final look at the question. Could we live inside a black hole? Based on the physics we are sure of, the laws of general relativity that we have tested and confirmed, the answer is a firm no. You would cross the event horizon and you would be pulled inexorably towards a central point where you would be crushed to an infinite density. Your existence would end. But based on the physics we suspect might be true, the theories of quantum gravity that are still being built, the answer is a fascinating may. The singularity probably isn't real. The center of a black hole is likely something else. It might be a dense ball of strings that would absorb you. It might be a bouncing Planck star that would eventually throw you back out, though you'd be long dead by then. Or, in the most optimistic and wildly speculative scenario, it could be a bridge to a new universe. Even in that best case scenario, it's not a place you can commute to. It's a one-way trip into a completely unknown reality with no guarantee of safety. The physics of our own bodies, the very atoms we are made of, might not be stable in such a place. The word live might not even mean the same thing. The real value in asking this question isn't about planning a future home. It's about pushing our own understanding. Black holes are the ultimate laboratories. They are the places where our theories are pushed to their breaking point. By imagining what it would be like to go inside, we are forced to confront the biggest gaps in our knowledge. We are forced to ask what space, time, and matter are really made of. The universe is far stranger than we can imagine. A century ago, black holes were just a weird solution in Einstein's equations. Most people, including Einstein, thought they couldn't be real. Now, we've taken pictures of them. We've detected the gravitational waves from their collisions. They are a real and fundamental part of our cosmos. What we'll discover about their interiors in the next century is anyone's guess. Maybe we'll find a way to test these ideas. Maybe a new genius will come along with a theory of quantum gravity that gives us a clear answer. For now, the inside of a black hole remains one of the greatest mysteries there is. It's a place where the known universe ends, and our imagination has to take over. And as long as there's a mystery, we'll keep asking the questions, even the ones that sound like they're from a science fiction movie.